everyone, so we're back here and we're looking at a new unit. So this unit we are discussing parametric equations, and this might be your very first time even hearing of this concept, parametric equations, and you're probably maybe wondering, well, what is it? So a parametric equation, or equations, it's a set of equations when both, write this down here for you, when both elements of a relation, x and y, can be written in terms of another variable. And this other variable that they're written in terms of, this variable is t. Now, we often call t, this third variable, a parameter. All right. So the idea is that I have this x comma y, this relation, because it might not be a function, where x is some function with respect to t, and then y is some other function with respect to t. So here in this video, we're going to focus on interpreting a parametric equation and how do we graph them. And then based off the graph, we just quickly analyze, is it a function or not? So let's see what we have for our first example. So consider the set of all ordered pairs x, y defined by the equations x equals t plus 1 and y equals t squared plus 2t. So here we're going to find all the points determined by -3, -2, so -1, 0, 1, 2, and 3. So how we graph this, we are going to make a table. So our first column will be time. Okay, so we have one column being our time interval. And then for we have a column for x equals t plus 1. That's a second column. And then we're going to make a third column of y equals t squared plus 2t. And -3, -2, see -1, 0, 1, 2, and 3. How we get the order pairs, because really we're going to graph this like we normally would, x comma y. But the x and the y we are going to find according to the t value. So for example, so at t equals -3, place -3 into our x function, -3 plus 1, we get -2. And then place -3 into our y function, we get -3 squared, which is 9, and then -6. So 9 minus 6, that would be +3. So that ordered pair would be 2, 3. Because you can also add a fourth column. I guess it would be a fourth column where you would write out the coordinates. But we can just say -2, 3. And we repeat that. -2 would give us, for our x component, it would give us -1. Placing -2 into our y component, we would get, let's see, 4 minus 4, so 0. And then for -1, we get 0. -1 into our y component, we would get -1 squared, so 1 minus 2, so -1. You might be wondering, are we always going to have the given t interval? Typically, yes. Whether it is that you're given a table and they tell you what t values you use, or they'll write to the side here like -3 less than or equal to t less than or equal to 3. You'll be given that, okay? And we just often assume that the increment, the change between each t value is 1. But back to our table. Plugging 0 in, let's say we get 0 plus 1, 1, and then we get 0 plus 0 is 0. So just do this real quick, go through this. Okay, so now we just plot them, and that's it. So let's do this. You have -2, 3, And I'm going to label here what time value that was for. So t equals -3. Okay, so then -1, 0. And I encourage you to do this as well. Label your points according to their time value. 0, -1. Okay, 1, 0. That was t equals 0. 2, 3. Let's see, 3, 8. 3, 4, 5, 6, 7, 8. Yep. And when I made this grid, I knew I was going to run out of room. 4, 15. So 8, 9, 10, 11, 12. Yeah, 4, 15 is like way up here, so I won't place that dot for the sake of not making it messy. So you would have another point out up top. Okay, so we have our points down. When we connect, we are going to add here arrows throughout the graph to signify as our t-value passes what direction our graph is going, because that sometimes is very important when we go to application or just talking more about the parametric equations as to where the direction is going. So we have here what appears to be, so I'm going to include arrows. And then also it's a function. We know what a function looks like, how we determine if it's a function. So this parametric equation is a function, or I should say yields a function. Because we don't want to say the parametric equation is a function, it yields a function. All right. Now, so we're just going to continue practicing. I have 2 more of these parametric equations that we're going to graph and see what we can get. So let's look at this one. So let's graph this parametric equation. X equals t squared minus 2 and y equals 3t. So we have our interval -2 to 3. Let's do this. So actually, you go ahead. I'm going to stop here. Go ahead, knowing our interval and knowing what we do with our table, go ahead and complete your table, and then I'll come back with you to work on our graph, okay? So pause now and fill out the graph. All right, so we have our completed table. Let's go ahead and graph. So 2, -6. So 2, 4, 5, -6 would be right here approximately. So this is t equals -2. All right. So we have -1, -3. Okay, so that's t equals -1. That's 0. We have -2, 0. Okay, and then -1, 3. We have 2, 6. All right, then we have 7, 9. So 2, 3, 4, 5, 6, 7. Let's see, this is 6, 7, 8, 9. Yes, all right. So now we connect our points. Okay, and we place our arrows to signify the motion. And question, does this parametric equation, set of parametric equation, yield a function? And knowing how we test it, we can say it does not. So these parametric equations, or this parametric equation, does not yield a function. All right. So again, just focusing on graphing, we're good. Last one. So it's not that bad, really, when you think about it. You're taking the two components, the x and the y, placing your t-value in, plotting the points, and here we had a parametric equation that did not give us a function. So let's look at what we have now. For our last one, so graph the following parametric equations. So we have our x component being 3 cosine of t, our y component being 3 sine of t. All right, let's do this. So this is involving trig functions, which is pretty nice. Gotta love those trig functions, right? Yeah, okay. So we have our time value 0 to 2 pi, and let's say that our increment, meaning our change, let's make our increment pi over 2. So if we start our t-value of 0, I add pi over 2 to get the next t-value. So adding another pi over 2, we get pi. Adding another pi over 2, we get 3 pi over 2. Adding another pi over 2, we get 2 pi. Okay. Again, you'll know this by the table or by the problem you have. So let's do this. Knowing our unit circle, cosine of 0 is 1. So 3, cosine of 0 is 3. Sine of 0, 0, so 0. We're going to have a lot of repeating here. Cosine of pi over 2 is 0. Sine of pi over 2 is 1, so we get 3 here. And this is going to start repeat. So cosine of pi is negative 1, so we get negative 3. Sine of pi is 0. Okay, cosine of pi over 2, that's 0. Okay, that's negative 1, so we get negative 3. And then cosine of 2 pi is 1, so you get back to 3. And 0. Alright, it wasn't that bad. So let's graph this and see what we get. So let's do this. So we have 3, 0. That's at t equals 0. We have 0, 3. That's, let's see. That is, oh my goodness, pi over 2. And then we have negative 3, 0. That's t equals pi. Then we have 0, negative 3. That's t equals 3 pi over 2. Back to 3 zeros. That's t equals 2 pi. Now, you might have this urge to curve this around. And really, the previous problems, one mistake I can admit to is that in our previous problem, I added a little bit of a curve within each section. Technically, I should have gone straight from one point to the next, straight to the next one, straight to the next one, straight to the next, and not have included this curve. That curve we achieve by decreasing this increment. So having like 2 or negative 2 to negative 1.5 to negative 1 to negative 0.5 to 0 to 0.5. So decreasing that amount of change gives us a better curve. Back to this one, I might have this desire to put a circle here, but we cannot. So what we have to do is 1 to 1, to the next, to the next, to the next. So we can see that this is not a function. So I want to end with asking this question, because we are going to explore, maybe, hopefully, more of this x equals cosine of t, y equals sine of t, and maybe the values in front will change. So what do you think would happen if this increment, say that we had pi over 2, what would you think would happen if that increment decreased to, say, pi over 3 or to pi over 4? Because pi over 4 we would have 1 point within each of these quadrants. Then what, pi over 6, or even better, pi over 12, or even better, pi over 32, or even going crazy, like pi over 64, when our increment's really, really small, we would get a lot more points here. What do you think would happen? I actually already hinted to it. It's going to give us a circle. And we'll learn that when our parametric equation is x equals a value times cosine and y equals a value times sine, that this will yield a circle with a radius of our value. So imagine for a moment, this is what I'll end with. Imagine if I had a parametric equation of x equals 5 cosine of t, y equals 5 sine of t, it would yield a circle centered at the origin with a radius of 5. But we'll explore more into that. Good luck, guys, graphing these parametric equations. I hope you have a better understanding of what a parametric equation is. And this is the first time asking this, but if this was helpful to you in understanding what a parametric equation is, please hit the like button down below. We're going to continue looking at parametric equations. So I'll see you in the next video, guys, where we'll just explore more into this. And again, good luck practicing this and graphing these functions. Or maybe not functions.